have a quick review of this null factor law. Let's look at this again. So do you understand how we got 24 equals 4x squared plus 4x? Yes, no, yes?
No, I missed the front part of it, so I don't know where you got that from.
Okay, so do you understand how we got to the area equals 4x squared plus 4x?
Yeah, I got to that.
Yep, okay, so we know that that's the total area of this shape, right, in terms of x. We know that it told us the total area is 24 meters squared. So therefore, 24 needs to equal this. I've just substituted in what the area is.
Oh, so we're using the area to solve it.
Yeah, because it's told us the area. So then I got to that, right? Now you could do trial and error to try and make it equal 24. Do you know what I mean? Like left-hand side equals right-hand side. Like if you put in x equals 1, you're going to find that this side will equal 8. And 24 doesn't equal 8, therefore x can't be 1. But if you put in x equals 2, you'll find that 4 times 2 squared, which is 16, plus 4 times 2, which is 8, that equals 24. So you can see that x equals 2. You with me?
Yeah, I get that.
Yep. Okay, so there's that way of doing it, which is trial and error. There's another way, which is the null factor law. What we're trying to do is if you take this number and make it on one side. So if you make this equation equate to 0, and then you factorize this, right? The beauty of why we can factorize, and this is called the null factor law, and one of the reasons why we factorize is for this. Once we do this and we get it into the factorized form, can you see that this is a factorized form?
Yeah, I can see that.
Yep. Well, the beauty here is if I can make one of these factors equate to nothing, can't you just do like anything times 0? Isn't that always going to equal 0?
Yeah, I get that, but like, why are we doing it?
Okay. Yep. Cool. So do you understand the math behind here? So can you understand that a possible solution for this would be x equals 2? Because if you substitute in x equals 2, this factor is going to equal 0. 0 times anything is going to make it 0, which is true, right, for the equation.
Yeah.
Yes? Also, I could also make it for this equation, I could substitute in x equals -3. Do you see that if I substitute in x equals -3, that factor is going to make it 0? 4 times 0 times anything is going to give me 0. Would you agree?
Yeah, I agree with that.
So,
I just was confused of how that, like, why we have to get 0 first. Like that.
So why we're getting 0 is because before we had to use trial and error, right? Over here, we had to guess what makes it equal 24. Do you see what I'm saying? Like, you'd have to put in x equals 1 to try and make it equal 24. Can you see what we're doing? You with me? Yep. So do you see how, oh, well, I was lucky it was x equals 2. You know what I mean? So you could have been trying for a long time. Like it could have been x equals 72. And then you might have been keep on going, oh, I've got no idea. You with me? So one of the tricks that you can do, it's not really a trick, but if you think about this, and it takes a bit of thinking, if this equals 0, right? If we factorize it, isn't it just telling you quite easily, as long as you're not adding or subtracting on the end of this, if you can factorize this, you can make one of these factors equal 0 and it reveals the answer because it equals 0. Because what we're really trying to do here is we're just trying to make one of these things equal 0. So for example, if you can make that equal 0, well, this times 0 is going to equal 0, right? Can you see how that gives us our answer?
But like when you said that x equals 0, then why is like why doesn't 4, when 4 goes into x, why isn't it 8?
Can you just ask that question again?
I said that when you said we were trying to make x 2, why didn't 4 into x make 8?
Which 4 into x?
The one with the -2.
Yeah. So we want to put in we want to make this factor because it's called the null factor law, right? Why do you think we call it the null factor law?
Because there has to be 0.
Right. We want to make the factor equate to nothing. So what number would you have to put in here to make this equal nothing?
0. Sorry, 2, but like make 0.
Yeah, you'd have to put in 2 to make it 0. So if you put in 2, so if x equals 2, right, it's going to be 4 times 5 times 0. What's 4 times 5 times 0?
Oh, I thought we were going into the brackets like 4 into x and 4 into 3.
No.
And then that's why I was like, why isn't it ending up?
No. Does that make more sense now? So can you see 0 equals 0, right? So over here, another possible solution is, what about this factor? What could you make to make this null? What would you have to make x equal? Right, so x equals negative 3, right? So if you substitute x equals negative 3, that's going to be 4 times 0 times negative 5. And that is going to be true. Now let's just choose another number, just for the sake of it. Let's choose 1, right? If you chose 1, what will happen is that's going to change to 4, right? Times 1 minus 2, that'll be negative 1. So 4 times 4 is 4, times negative 1 is negative 16. So can you see that that does not equal each other? So therefore, that's not true. Because 0 doesn't equal negative 16.
Yeah, I can see that.
Yeah. So what we're trying to do here is while we factorize it, rather than guessing and checking, if we factorize it, then we can use the null factor law and go, hey, to make this equal 0, what does x need to be? Well, x needs to be either negative 3 or 2. Because if you make it equal to negative 3, this factor is going to be 0. 4 times 0 times negative 5 is going to give me 0. If it's 2, this factor is going to be 0. 4 times 5 is 20 times 0 is 0. So it makes the statement true. If you put any other number in there besides negative 3 or 2, it's not going to equal 0. Does that make sense? Sort of the math of it?
Yeah, that makes sense now.
Yeah. So really, instead of guessing or checking, and this is really what we're trying to do. So instead of guessing or checking, and thank you so much for working through this with me. It helps clarify, I think, a lot of thinking for everyone. So instead of guessing or checking, right, what we can do is we can actually just make it equal 0. So just move this over the other side. Then you factorize. Don't forget you always take out your common factor if you can first. 4 was common in all this. Then you factorize it. Once we've done that, well, you can just make one of these factors equal 0. It's going to make that statement true. So it reveals, once we factorize, what the solution to this is. And as I said, this is where we're trying to do a bit of application. You know, we're trying to show you how this works. So when you've got these, questions about how you can set up algebraic equations to help you solve and find a solution.